Death and birth are not opposites in the cosmos. They are partners in a continuous cycle. Nowhere is this more evident than in a process known as triggered star formation. A single supernova, the cataclysmic explosion marking the death of a massive star, can unleash energy across hundreds of light years, igniting a cascade of new star births in its wake. Imagine a dying star sending out shockwaves, like ripples in a galactic pond. These shockwaves compress vast regions of the interstellar medium, pushing loose clouds of gas and dust into tight, dense pockets primed for collapse. This is not random chaos. This is orchestrated regeneration. These compressed regions soon become new molecular clouds, where gravitational collapse begins. Protostars ignite, planets begin to form, and a new generation of stars emerges, all born from the violent death of a single ancestor. In this sense, every new star is a tribute to the one that came before it, a legacy written in light. But the shockwaves don't stop at mere compression. As they sweep outward, they collect additional material from the diffuse interstellar gas, sweeping it together like cosmic snowplows. These dense ridges of swept-up matter form new clouds where no clouds existed before, expanding the galaxy's capacity for star formation and seeding life into previously barren corners of space. Even more remarkable is the chemical enrichment these explosions provide. The shockwave doesn't just carry energy, it carries the heaviest elements in the universe: carbon, oxygen, silicon, iron, all forged in the dying star's core and ejected into space during its final, fiery breath. These elements mix with the newly forming clouds, enriching them and increasing the chance of rocky planets, atmospheres, oceans, and perhaps life itself. So, the death of a star isn't just a moment of destruction. It's a catalyst for creation, an artist's hand that paints new worlds into being with the ashes of the old. In the Triangulum galaxy, regions affected by triggered star formation appear as glowing shells and arcs, huge curved structures of ionized gas surrounding dead stellar cores. Through telescopes like ALMA and James Webb, astronomers can observe these shells in incredible detail, watching the way gas flows, dust collects, and stars ignite. In some regions, entire star clusters have been born from the wake of a single supernova. This domino effect of stellar birth can continue for millions of years, as each generation of stars eventually creates new shockwaves, which compress new clouds, which birth new stars, and so on. It's a cosmic chain reaction, not unlike a forest fire that leaves fertile soil in its wake. But with stars, what rises is not just new life, but new possibilities. This feedback cycle plays a crucial role in galactic evolution. Without it, galaxies like Triangulum might have exhausted their star-forming materials long ago. Instead, they recycle, rejuvenate, and regenerate. Triggered star formation ensures that galaxies stay dynamic, that they grow, that they evolve. It also means that our own Sun and Earth may owe their existence to a supernova billions of years ago. Studies of ancient isotopes in meteorites suggest that a nearby supernova explosion occurred just before our solar system formed, enriching the cloud that became the Sun with short-lived radioactive elements. In other words, we are literally made of stardust. And the star that helped make us may have died to give us life. That's not just poetic, it's scientific fact. So when we gaze into the spiral arms of Triangulum, and we see the glowing tendrils of new star clusters wrapped in clouds of pink and blue, we're not just looking at stars, we're looking at a story, a cycle, a legacy of cosmic rebirth that has played out for billions of years and will continue for billions more. And at the center of that story is a simple truth: from death comes life. In the most literal sense, the stars that explode, Become the stars that shine.